Have you ever thought about the value of software testing? Why sometimes it's avoided by developers? And how it could help your software projects? In this video, I'll help you understand some basics of software testing. We will explore topics like the different types of tests, why you should test your software, and why is testing effective. So, how secure would you feel using a system that has not been tested? Let's say that you intend to buy a car but no testing was done by the engineers who worked on the car. They built the car basically or solely based on their engineering experience. How would you feel about driving this car? Would you feel secure? Would you feel that it works well, that it functions well? Would you even consider driving the car if you knew that it has not been tested or driven before? Well, that's kind of one of the reasons why we test software, to give a better sense of quality to the end user of the software. Now let's look at some reasons for testing. The first is compromise. So depending on the bug of the software, an error can compromise a person, a group of people, or a whole organization. Imagine you're implementing a financial software and due to a major bug, millions of dollars are lost in transaction. Number two, quality. As a software engineer, it is your responsibility to ensure the quality of the software you produce. Implementing high quality software can also lead to growth. Three, security. Having a secure software is essential to protect against malicious attacks and prevent data breaches. Number four, cost. Saving your organization time and money. Testing is one of the most cost effective ways to ensure quality and reliability of your software. And finally, there are many more reasons to test, and you will see explicitly or implicitly throughout the next slides. So let's go a little bit deeper on the cost of maintenance. So the cost of bugs that happens in production often outweighs the cost of prevention. Imagine a stock trading app down for 2 hours due to a bug in code that could have been prevented with proper unit testing. Calculate now the effort that it takes to debug an error, make the code changes, deploy it, and all the human resources related to all of this. You might have separate teams to create, identify, and deploy. If no testing is considered, errors might be common to a development team, where devs push code to a specific environment. Maybe that same dev would find a defect on another environment. It will go back to development stage and the developer would fix it, then the code goes to production. Well, that's too lengthy sometimes. You might have heard that test is a lengthy process, but practice makes perfect. Developers who have testing as part of their development process can speed up the way tests are written. Now, let's look at some of the testing excuses. Why teams, developers, and sometimes organizations choose not to test. Pushing responsibility to other teams. So, of course, we talk about quality assurance, but QA cannot test every change to code, as they're usually not aware of all changes in code. My software has few number of bugs. Even well-architected software with experienced engineers working on them should still run into bugs, especially with the growth of team size, lines of code, and patterns. Not part of the requirements. Software engineers should defend testing through input of non-technical requirements. Takes too much time. Like previously mentioned, fixing bugs tend to be more expensive than preventing them. Not necessary for delivery. Software testing could be part of delivery. Tactics that automate and run tests with code coverage analysis could be part of a delivery pipeline, for example. Now let's look at some software testing principles. First one is, can I test everything? So the answer here is typically no. You cannot test everything. Testing all scenarios in software is just not feasible due to the number of possible combinations and scenarios that can appear as software evolves. One must prioritize what should be tested, and we will talk about this when we get to the section about the types of software testing. When should I test? The goal is to figure out what types of tests make more sense for the software that you are developing and what part of the software you should prioritize testing. Then you can figure out when you should test a specific software. What should I test? Some features of software are more critical than others, like a banking transaction module might be higher priority than like a notification section of the software. So you must understand what is more critical to failure in your application. For test location. So there are different software out there. So different types of software may require different tests. A web app may require strategies that differ from desktop apps that differ from mobile applications. Are there perfect tests? There is no test perfect software. As Dijkstra states, testing can help find the presence of bugs, but not their absence. There is no bug-free software, and your test does not have to be perfect. Now let's look at a high level, some of like a high level vision of the types of tests out there. So there are many testing techniques out there, such as load testing, mutation testing, and so on. But let's think about how developers can test on real world scenarios on many applications like web, desktop, and maybe even mobile. So we will focus on three testing types. First is unit tests. They're responsible for testing a single unit of an application. Second is integration tests. They're responsible for testing integration between software components. And last but not least, end-to-end test, responsible for verifying that all components of a system can run under real-world scenarios. So let's talk about unit tests. When the goal is to test a single feature of a software, unit test is the correct choice. Unit test validates a unit or small section of the code. Unit tests should be small and really fast to run. So let's say you have a class. Within that class, you have methods. A unit test would test a part of the method. It could test the exceptions thrown by that method. It could test when the method does not throw exception. It could test edge cases of that method. And each one of these tests are usually a single unit test. So you'd have multiple unit tests for a single method. So let's look at some of the advantages and disadvantages of unit tests. So like previously mentioned, unit tests are fast, they're small, and they also serve as documentation. So, like I mentioned, you have a unit test, it's testing for various scenarios within a method. So, let's say you're looking at an application, the first time you're looking at some code and you look at a method and you wonder, how would this, what are the scenarios where this method could be, ran? What would cause this method to fail? What type of parameters would cause this method to fail? And sometimes looking first at the unit test could help you clearly understand the behavior of a method and could be really useful as documentation. Some of the disadvantages is that since we're testing a small section of the code, it might lack reality, right? Because code doesn't work usually doesn't work through like a single method. It works with interactions between methods. So you call an event which that interacts with various methods, various parameters, and data. So it can lack reality in that point of view. And of course, it does not detect all bugs. So how are unit tests effective? They're low cost and high value, or they should be. They should be low cost to write and should produce high value to the business. They should have some type of automation. You could run them in an automated fashion through your CI and CD or any tooling that integrates into your development lifecycle. They should focus on the essential part of the code. Of course, this is not like a strict rule, but you do want to focus on the essential part, on the essential business rules, on the business rules that, cannot fail at any instance. That would, if it does fail, it would be, it could compromise. So they should provide value and test part of the code that are important to the core business of the application. Now let's talk about integration tests. So unit tests, like I mentioned, they test a unit of an application. However, you cannot be sure that your system works if you rely only on unit tests. There might be a necessity to validate how different parts of the software integrate with each other and external systems such as databases, message bus, eventing, and also other APIs and systems. So integration tests or integration testing helps you validate how components work in integration with these external systems. So when we look at this image here, we have a system that executes, it runs through a business rule or business classes, and then it connects to a database. So the integration test could actually test if your system is correctly integrating with the database. Depending on the architecture that you're building, if you swap databases, your integration test can verify, even if you swap databases, that swapping that database did not break the integration between your system and this new database. So that's just an example. And when we think about unit tests, it's important to maintain a balance between unit and integration. So integration test validates integrations with external systems. Therefore, tests tend to be more expensive to maintain than unit tests, right? You usually have a higher protection against regression, right? Regression testing refers to a software testing techniques that reruns, non-functional and functional tests to ensure that a software application works as intended after any code changes, updates, revision, improvements, or optimization. So the number of tests between integration and unit can drastically differ from application to application depending on the need. So there is a necessity to understand the value of unit tests and the value of integration tests and when to write them so you can keep a healthy balance. Now let's talk about end-to-end tests. So end-to-end tests consists of manual tests done by a person or a program. It validates a system where all its components are taken into consideration, such as infrastructure like the database, service bus, and other integration. The user interactions such as the platform or the browser navigation, the back-end processing, front end are also covered on end-to-end tests. So these tests, they cover functionality of the entire software application with real-world end users or simulation of or replication of factual data. At this point, the code or database is irrelevant. The idea is to provide an input to the system and expect an output through the same process as the end user. It would be similar to you when it comes to like the car scenario, instead of testing how the motor works with other components or how the motor integrates with other components, you actually, get in the car and drive the car. You have that driving experience. It would be how you can think of end-to-end testing. So end-to-end tests are realistic. Therefore, when doing this type of test, you should use the platform in which the system is running on. You could use like a web browser to verify a web application. You can use an iPhone to validate an iOS application, or you can use Windows, for example, to test a desktop application. So you have to use what the end user is using or simulate what the end user is using. So let's look at some of the advantages. They are realistic, right? Methods are not tested in isolation. Instead, you simulate the testing from the desired platform with inputs and outputs. They're reliable for regression. So the test could go through all layers of the application, starting with the front end. And it could also give a good confident booster. For like the quality assurance team, integration tests could be used as a final step, and then end-to-end tests could be your UAT before releasing to production. And that will give you more confidence that existing functionality did not break. And some of the disadvantages are performance. So tests can be slow compared to unit tests. Imagine everything a system test has to do, including starting, running the entire system with all of its components. You know, the test also has to interact with real, you know, applications and actions, which can take a few seconds. You have environment configuration, so you might have to set up a database and require a complex environment configuration. And you also have behavior. So behavior can vary, right? Depending on the environment, you can have a faster behavior on an environment or a slower behavior on the development environment and a really fast behavior on a production environment that could lead to a failing test depending on the performance of the environment. With all of this, we have a testing pyramid. So when working with testing, it is important to have a clear understanding of the different test levels, their cons and pros. Therefore, your team or yourself can invest on whatever makes more sense to the objective of the organization or the project in hand, right? So you have the following pyramid, which contains all level of testing, right? So the higher you're in the pyramid, the more complex it is, but the more realistic it is, right? So you have the unit test at the bottom, and then you have integration test in the middle, and finally you have end-to-end test that covers, the entire functionality of your software at the top. So I hope this video helped answer some questions you had about software testing. You should have some insights on why software testing is important. What are some of the software testing techniques or types, and why you should consider software testing in your projects? There's, I would say, there is a lot more that involves software testing. However, understanding the pyramid, understanding the software types, understanding why you should test, when you should test, and having a global vision is critical to any software developer, development team, architect, or, general IT developers or people thinking about writing good quality software.